Hi, I'm Sherry Taylor. I am the engineering teacher here at Yerba Buena High School. I've been here since August I've recently earned my CTE credential, which is based on my engineering degree from University of Michigan. I came to the Bay Area quite a while ago to work on computer projects. I worked during the first and second internet bubbles and really enjoy doing that. So after a period of time, while raising my kids, I helped start robotics clubs and robotics teams at all the schools where they went to school. And at the high school, they were looking for someone to teach robotics. So I taught robotics there for 3 years while I was earning my CTE credential. So here I am at Yerba Buena, and I'm very happy to be here. It's a great school, and I am finding that students really resonate with my class because the emphasis is not on the math and not on writing, but on making projects and thinking about how how ideas they have can turn into products. So I use the curriculum that they use is from Project Lead the Way. There are two classes I'm teaching right now. The first one is called Introduction to Engineering Design, which focuses on the design process. There's a little bit about that in the video. And then the second class I teach, which is for 10th graders, typically the second class in the sequence is Principles of Engineering. Think of it like a physics lab, where you learn about physics through doing, and then we go back and we go over the math and try to bring things together that way. The third class in the sequence is digital electronics, and the last is a engineering design class. So it's basically a capstone. One of the things that is also unique about this class is students work in teams, they collaborate. There is some individual work that are individual projects they do, so they get a chance to show more of their individuality and their mastery of the design process. And they learn how to overcome those struggles that many people do, of learning how to work together in a team and how to communicate. They make new friends because these classes are for all grades. So students that are 10th graders will work with 9th graders, 11th graders, 12th graders. If you have any questions for me, you can always contact me at taylorsh@eastsidehunionhighschool.org. So I left a couple things out earlier in the video. First of all, the last class that students take will be the one where the capstone class. In the capstone class, I'm planning on having the students convert the go-karts that have already been some of them have been already converted to from just gas engine to hybrid, some electric or electric powered along with the gas powered go-karts. And I am planning on having the students actually convert these to autonomous go-karts. Probably also be able to be controlled with a remote control, but also be coded so that they can, travel for long distances without anyone to be nearby. The other thing that I wanted to just kind of reflect, just note that by doing any kind of work with robotics, which we are doing in the second course of the sequence of 4, and more in the third sequence, and then of course in the fourth class of the sequence, there will be a lot of exposure to robotics. So robotics is a huge market for people of all different levels, inventors, designers, testers, as well as people that just know how to work with them and fix them and understand how they work. So one of the certifications that students will be able to get uh, starting next year, and even some students this year, can test for a Fusion 360 certification. Fusion 360 is a 3D modeling software that is used in industry. So I hope that this answers any questions, and I hope you enjoy the rest of the video.
So these are our go-karts. Our students have been working over, I'm not even sure how many years now, improving these go-karts, making the engines more efficient, and then adding electronics. As you can see here in this video, there is basically a SparkFun controller and a breadboard connected to start the process of converting part of and the control of the go-kart, the power for it, to a hybrid system. The students really enjoy using these go-karts. We do have safety equipment that the students use when they're driving them. And here's a preview of the metal shop equipment. These equipment is shared with the space with the go-karts. This is a CNC machine and a similar one. As you can see, these machines are new. We also have saws. Welding stations. And all kinds of metal managing equipment, sanders, etc. And here is one of the videos of our makerspace. So this is one of the robot arms that the students will learn how to use. Two of our 3D printers, welding simulator stations, and another welding simulator station, and a second robot arm. This video shows you the two Raise 3D printers that we have been using, and just another walkthrough of the space. The tool kits are for the robotics work that's just getting started right now. And we have two cutters. This is a CNC machine, a smaller version. And on the right, there is the left, that's one of our cutters, and this is a high pressure water jet cutter. And here's a video of our computer lab. We have 40 computers with each computer has 2 monitors. And what we do projects. So first of all, here's some work from Fusion 360. So this is an animation of a cube puzzle. This is the second project the students work on, and here is the cube puzzle assembled, and projects. So here is one of the first project is a carnival game, and you'll be seeing some of the carnival game work interwoven with some cube puzzle work, which is the second project. The students create a launcher made out of popsicle sticks and rubber bands, and they launch small bean bags into the holes to do the testing. And this is what students work for their cube puzzle. And more cube puzzle work. And another carnival game. And more about the design process. So the design process is 6 steps. You start by defining the problem. You interview stakeholders to get to know what the issues are that they're running across. You research into prior solutions. You come up with a criteria and constraints. And then you research the problem. You brainstorm possible solutions and select and justify your approach. In the develop solution stage, you create a detailed solution plan, and then you basically implement a prototype. You plan the testing, do the testing, collect and analyze the test data. Sometimes the data shows that the prototype that you've come up with isn't the right one, so you reflect on the design, recommend improvements, and redesign if necessary. Finally, when you're done, you'll document the project and communicate out the project. So thank you for watching this video.